Okay, so can you all see my screen? Can everybody see my screen?
Yes, please.
Yes. Yes.
Okay, what's on the screen right now? Please let me just be sure that I share the right screen.
Computer basic skills. Mouse tutorial. There are a lot of
Okay,
headings.
no, that's not the right screen. Let me there's okay, can you see my screen?
Yeah, we still have computer basics.
Okay, that's great. Okay, let me introduce myself. My name is Wisdom. I'm a software engineer and a web developer by profession. And I'll be taking you guys on this course, Basic Computer Training. I'm sure some of you here are doing the professional course on cybersecurity. Am I right?
Yes, you're right.
Yes.
Okay, that's great. That's great. So, and I'm sure you have already seen the website of K2 Cybertech, where you guys take your courses online.
Yes.
Okay, so I'm the one. I'm the one behind the creation of that website. I manage I manage the IT department of K2 Cybertech, and I will be the one taking you guys on basic computer training because we've realized that a lot of people that go in for these professional courses, cybersecurity, DevOps, AWS, you tend to fail at the level of your interviews when you've completed your course, you've gotten your certification. You tend to fail at the level of your job interviews because you're being asked some little basic questions on computer that you think that you will never see it in your life, but there are some really tricky questions. So we saw the need to refresh our memory on on computer basics. So I hope this course will help a lot of you guys here. So with time, I would like to know everyone here. I would like to know you guys by name, personally. And this is how I always go along my classes. I like us to interact because there'll be sometimes that I'll call your name and say, okay, please, can you help us read this particular part of the note? And I do the explanation. So I like a very interactive class, okay? So is that okay by you guys?
Yeah, that's okay.
Yes.
All right.
I'm listening, no. So if you don't talk, I'm listening. I'm taking down attendance.
uh,
Yes, so it's okay, Prof.
okay, so let me first share what we shall learn in this course, what you are expected to learn, basic curriculum. Computer training basic curriculum, the overview. So it's a 2 month course, please. So during these 2 months, we're going to look at introduction to computers. We are going to talk about basic computer operations such as the mouse, the keyboard. We'll talk about computer softwares, type of computer softwares, computer applications. And very important, we'll be looking at working with Microsoft Suite, such as working with Microsoft Office, Office Word, Excel, PowerPoint. There are a lot of people that don't know how to use Microsoft Word, Excel, and PowerPoint. Right. So it's really, really important that we master this. We'll talk about the internet, the email and internet, how to do proper research on the internet, how to communicate or using the internet, your email, Gmails, and other emails, providers. We're going to be looking at this. We'll also be looking on online safety and security. Online safety and security. We're going to understand the basics of cybersecurity. Obviously, you guys are already doing cybersecurity with Prof. Fabrice, but we're just going to look at the basics. Yeah. We'll talk about protecting your information, privacy, identifying common threat, how to secure your computer, your local machine that you're currently using. So we'll talk about browsing safely on the internet. These are very important things. And last but not the least, we'll be looking at what we call basic troubleshooting. That is identifying and solving basic computer problems that we face in our day-to-day life, and also some maintenance tips. So these are stuff that we'll be looking at for the next 2 months. So I admonish every one of us to always be attending classes, because obviously we'll be sending the recorded videos, but you know, when you attend a class live, it's more, you tend to understand more, and you're less distracted rather than when you're watching the recorded video. And during a live class, you can always ask your questions, okay? You can always ask your questions, and we'll try our best to answer them. So let's move forward to agenda of today. So our classes will be between 2 to 3 hours. 2 to 3 hours. I hope that's not too much. 3 hours. Is 3 hours okay with you guys?
Yeah, it's okay.
It's okay.
2 hours.
2 to 3 hours, depending on the mood and the interactiveness of the class. But you know, if we're asking a lot of questions during the class, it's going to take us more time. So that's why I said 2 to 3. So before we start this course, basic computer training, we have to know why we are studying it. You have to know why you're studying, especially for you that you're going through this, the professional cybersecurity. You may be going through the cybersecurity course or the DevOps or the AWS course. So you must know how the knowledge of computer basics is going to help you in your professional career or in your learning journey. So we have to know about that. It's very important. So importance of computer basics to your tech career. The first thing that we'll know about is a foundation. It is a foundation for advanced learning. Understanding basic computer operations is fundamental for grasping more complex concepts in AWS, DevOps, and cybersecurity. Because you're going to realize that during your journey, when you're learning your cybersecurity courses, there'll be some little things that Prof. Fabrice will be talking about. If not, he has already spoken about that. You've surely asked him a question that, sir, how do we do this? How do we do this? And he referred you like maybe to say, go and do some research on this. Those are kind of basic things, computer knowledge that you must have, and it will help you understand more complex stuffs. So basic computer, the knowledge, what you're going to learn here is a starting point to something bigger in your tech journey. Knowledge of basic computer functions, file management, software usage forms, and bedrocks of any tech-related career. Okay, we also have improved problem-solving abilities. Basic computer training sharpens analytical skills, enabling students to troubleshoot issues effectively. So as we said, when I was going through the rundown of our curriculum, we said we're going to look at troubleshooting. Know how to maneuver those things. So that's why this course is very important. Problem solving is a crucial skill in AWS, DevOps, and cybersecurity, while identifying and fixing issues swiftly is essential. Guys, don't worry. At the end of this class, at the end of each class, I'll be sending the notes in the group. Like what you
Okay.
see right now, I'll be sending them in the group. So you
Mhm.
can download later and revise, okay?
Yes. Thank you.
Welcome. Okay. The next importance of learning this course is competitive edge. Computer literacy is a fundamental requirement in the tech industry. Basic computer skills provide a competitive edge in the job market. I think that's self-explanatory. Those who have computer skills tend to get the jobs out there because the world is going digital and it's really, really fast advancing, especially in the field of cybersecurity, AI. So you see that you, with your knowledge of computer or tech, it gives you a competitive advantage over your peers out there. That's why you see everybody now is diving into tech. Everybody is diving into tech, no matter the age group. Okay. Employers value candidates who are proficient with computers and can adapt quickly to new technologies. So you see that with your knowledge of basic computer, it will help you to adapt quickly, to learn faster. Because as I said, technology is advancing. So you realize that in your journey, you have to be learning new things every day. New things every day, so that you can be up to date with the trend. We have enhanced employability. Basic computer training ensures students. Please, if you have a question, you can just you raise up your hand and I will call you out to ask your question, okay? If you have a question along the way, just raise up your hand. Hope you all know how to do that. Basic computer training ensures students meet the minimum skills requirement for many entry-level positions in AWS, DevOps, and cybersecurity. As I said earlier, you realize that you go for some job interviews, you'll be expecting complex questions that will ask you in cybersecurity. You'll be surprised that you'll be shocked that the very first questions that they will ask you, it may ask you that what is a computer program? What is a computer program? What are the types of computers? So in order for you to give a good impression to your employee or the person interviewing you, you have to know these basic stuffs, okay? They may ask you that what is the difference between who is a computer literate? Can someone just answer that question for me? Who is a computer literate and who is a computer illiterate? Can someone answer the question for me? If you can answer, just raise up your hand, please. See, you see that this is very, very important to know this kind of stuff. It's very, very important because if you were in an interview right now, you would have been stopped. Facilitate online learning. Many AWS DevOps cybersecurity courses are delivered online. Basic computer literacy ensures students can navigate online learning platforms effectively. Let me admit the student. Okay, so you see that okay, so you see that right now we are in the age where there's more of digital learning. Like right now, what we are doing right now is called digital learning, e-learning. So if you don't have these basic computer skills, I'm sure you all here have your account at K2 Cybertech website, right? Is that true? Hello.
Me, I don't have one
Are you taking the professional course?
because I'm taking it.
If you are currently taking the professional training, you should have yours. You should have your account. So I'm trying to say that if you have your account, you realize that you have to log into your platform and you're going to see the course that you're currently enrolled in, right? And you see the videos have already been uploaded, right?
Yes, that's how it is.
So if you don't have basic computer skills, you will not even know how to log in, log out, access your course, take your assignments online, and the rest. So you see that it's very important to have basic computer skills. Okay, so those were some of the reasons or some of the importance of learning or undergoing this basic computer training. So now let's look at, let's go to the real deal. What is a computer? No, but let me just ask, does anyone here know what a computer is in your own language since you were born? I'm sure we all here have computers, or even if you don't have, you have already seen a computer in your life. So what do you think a computer is? I said I like my classes to be very interactive. So please, let's discuss. If you can answer, just raise up your hand. Or should I start calling names? Would you like me to call names?
I think the computer is a machine that processes raw data to give information of output.
Thank you very much. See,
You're welcome.
you've given a wonderful answer. Who else? Who else can say something, please?
What is a computer?
Just give, you must not give a perfect definition, just what you
Just
understand when you hear the word computer, just what you understand.
It's an electronic device that stores and processes data.
That's great. Thank you, Mrs. Therese. So a computer is an electronic device that accepts data, which is what we also call input. It processes the data and stores the result. It accepts data, processes data, produces output, and stores a result. That's the basic definition of a computer. So anything, any electronic device that can accept data, in bracket input, it processes the data, it produces the result, and it stores the result. That is a computer program. That's a computer, sorry. So you see that a computer is not only, because when we talk about a computer, you tend to think that it is only your laptop, your desktop. No, any electronic device. So you realize that a calculator is a computer. Your phone beside you that you're using is a computer. Even your watch is a computer. So what does a computer, what does it do? It accepts data. That's the first thing that it does. It stores the data in more technical terms. It does some operations, like some arithmetic and logic operations. Don't worry, we're going to see this in more details as we go along. And it gives you an output in a need and desired format. That's what a computer does. Now, I'm sure you'll be asking the question. I'm sure you should be asking the question that, how do we input data into the computer? And how does the computer processes that data? And how does it produce a result? Neat result, clean result, which will lead us to talk about components of a computer. In order to understand how a computer functions, how a computer operates, you must first understand what are the components of a computer. And there are three major components of a computer. We have the input unit, we have the system unit, and we have the output unit. So first, what is component of a computer? Component of a computer refers to the essential hardware and software element. So a set of tools, the essential hardware and software elements that work together to enable the computer to process data, to perform tasks, and execute commands efficiently. These components include input, processing, storage, and output devices that collectively make up a functional computer system. So we said it is the essential hardware and software element. So it is a combination of hardware and software elements. They have to work hand in hand. And examples of hardware elements are like, first of all, what is the hardware? Hardware is something that you can see and touch. We're going to see that in more details down, but let me just give you a recap. Hardware is something that you can see and touch. For example, your monitor, you can see and touch your monitor. Your mic, you can see and touch your mic. Your screen, your phone, you can see and touch. So they work together. Hardwares, they work together with softwares. What are softwares? You can see, but you cannot touch. For example, currently, as you're looking at these notes right now, you can see them, you can read what is on the notes, but you cannot touch it. Am I lying? You cannot touch a program, you cannot touch a software, you can only see it. So computers, hardware, and software work together, and that's what that's what we call the component. They form the component of a computer. So now we have to know exactly how these components function. Because our big question here was, it was our big question. How does the computer accept data? How does it process that data? How does it produce the result, and how does it store it? We must know that. It's very important, please. You may be asked in an interview. Are we together?
Yes.
Okay. I hope this class is on record. Okay, yeah, it's on record. So let's look at the three main of a computer. As we said, we have the input unit. This includes devices like the keyboard, mouse, scanner that allows the user to input data into the computer. So you input data into the computer, you input that raw data, because what is data? Data is raw facts. It's something that has not yet been processed. It's raw material. That's what we call data. And you input in computer using an input device, like we have the keyboard, the mouse, the scanner, and other input devices. So we're going to see them in more details. Now, the second component is the system unit, and this is the most important component of the computer. We're going to see them in details. We'll see how it works, the system unit functions, how it processes the data that you sent into it. So this is the core of the computer containing the CPU, that is central processing unit. It also contains the RAM, in bracket the memory, and storage that processes and store data. So all the processing of the data, all the arithmetic and logic operations are being done here in the system unit. And we're going to see exactly how it works. Okay? We're going to see exactly how it works. We have the output unit, the third component of the computer. The third main component, we have the output unit. This includes devices like the monitor, printer, and speaker that display or convey the processed data to the user. So after the data has been, after the raw material or the data has been sent into the computer using the input device, and it has been it has been processed using the system unit, it is now displayed to you and I in a clean format that we can understand using the output unit. Because this data that is being sent into the computer, it is, what do we mean by raw material? Unprocessed information, something that you cannot understand. For example, when you go to your phone, you're trying to send a message to your friend, like you type there, hey, good morning. Have you ever asked yourself the question that what, just by typing that, hey, good morning, do you actually think that, how will I put this? Do you actually think that the computer, when you type that word, hey, good morning, do you actually think that that's what was sent to the computer? No. Do we all know the computer language? What the computer understands?
Oh, language.
Binaries.
Thank you very much. So what is binary? Like in it is zeros and ones. Are you guys getting me? Are we together?
Yeah.
The computer language is zeros and one. As you type on your computer or your phone, what is being sent to the CPU are a combinations of zeros and one. Zeros and one. That's it. That's the language that the computer understands. So now that zeros and one are being processed with a lot of mathematical calculations, a lot of arithmetic and logic calculations that are being processed into the system unit to produce you a clean output that you are going to understand. So that's how it works. So let's look at a graphical representation of, let's look at a graphical representation of components of a computer. So as you can see here, the very first here is the input unit. The input unit is used to feed instructions, data to the system unit. And from there now, it goes to the system unit. Are we together, guys? System unit is made up of two parts. We have the central processing unit and the memory unit. We're going to see this in details. We're going to see the definition of the central processing unit, what it does, its role, and we're going to also look at the memory unit, its role in processing information. And once that is completed, our process data is supplied to us using the output unit. But now this process data is no longer called data. What is it called? Its name has changed. Can someone tell me? It's something that we call every day. It's a name that we use every day. What is process data? What is process data? Guys, please be participating so that so that I know that you guys are with me. So what is process data, guys? Should I call names? I'm seeing some names. I'm seeing Pierre. I'm seeing Mrs. Rita, Databot, Z. Process data is information. The opposite of data is information. The opposite of information is data. Once data has been processed, it is displayed in the form of information. Information is something that we can understand. Are we together, guys?
Yes, we are.
That's why you see here, output unit. It supplies information and results of computation to the outside world. These are questions that you may be asked in interviews. Are we now seeing why this course is important? Please, if you have your friends that you think they need this course, please go and tell them, please, let them join for the next class. It's very, very important because I've seen people fail interviews because of tribal things like this. I've seen people fail interviews because of tribal things like this. So process data is information. Okay, now let's look at a more technical representation of a component of a computer. Let's look at a more technical representation of components of a computer. I see this is a diagram. We have the input unit. We said data is being sent into the computer for processing using the input, through the input unit, using input devices like the keyboard, mouse, scanner. We have the mic. And that data is being processed. It undergoes a series of mathematical and logic operations in the system unit. And once it's done, it's being sent out in a clean and understandable format called information to the outside world. So it's being sent out as output using output devices like we have the monitor, we have the screen, we have the speaker. Okay. So now look at this diagram, please. You are going to see some more technical terms here. We have the input unit, we have the system unit. So the system unit is divided into two main parts. The system unit is divided into two main parts. The CPU, known as the central processing unit, and the main memory. The system unit is divided into two main parts. We're going to see them in details after this. And you must know the differences between these two parts. You must know its function. The system unit, let me repeat myself, is divided into two main parts. We have the CPU and the main memory. And again, the CPU is further divided into two parts. We have the ALU, also known as the arithmetic and logic unit. And we have the control unit. The second part of the CPU is called the control unit. I want you guys to look at these arrows. Please pay keen attention to these arrows. You see that the arrows interchange. So what does that tell us? That they work hand in hand. Without a component here, if a component here is removed, then you will not get the desired result. So after the CPU and the main memory have done their stuff, they send us the processed data, which is now information, through the output unit. Is there a question so far? Do you have a question so far? Does anybody have a question so far? We'll continue. Are we together?
Yes.
Yes, we're together.
Okay. Please ask your questions. Okay. If you have any question, ask your questions. I'm here for you. So let's look at each of these components and their functions, what they do. Okay. The input unit. Data and instructions must be entered into the computer system before any computation can be performed on the supplied data. The input unit is used to feed the instructions or data to the computer system. Examples of input units will have the keyboard, mouse, microphone. So I cannot overemphasize on the input unit. I think it's already self-explanatory. I've already explained this many times. So the input unit is used to input the data or the instructions into the system unit. That's all. That is role. That's all. Let's look at the output unit. The job of an output unit is just to reverse what an input unit. Just reverse that of an input unit. So if an input unit sends in data, the output unit sends out information. Input unit sends in data, output unit sends out information. So it supplies information and result of the computation to the outside world. Thus, it links the computer with the external world, or external environment. Examples are, we have the printer, we have the speaker, we have the monitor. So these are some examples of the output unit. Now, let us look at the big guy here, system unit. Remember, I said the system unit has two parts, central processing unit and memory unit. Please pay keen attention here, because this is where things will get a little bit complicated. So I really expect you guys to ask some questions here, because we have to know exactly how this functions, how the system unit functions. You must know exactly what happens with the data that has been sent through the input unit. How is that data being processed? So let's look at, go back to this diagram here. Remember, we said the system unit is divided into two main components. We have the CPU and the main memory. So let's look at the CPU. CPU meaning central processing unit. I'm sure we have already seen a CPU in our lifetime. This is for a desktop computer. In those days when they were still producing desktop, this is how the CPU is. Very big, very big. I'm sure we're familiar with this. Now, look at the CPU. As we progressed, we started using PCs, personal computers, like your laptop. So actually, you cannot see your CPU like with your desktop. Your CPU is inside your computer, and this is how your CPU looks like. This little chip, just small something like that. But that's the brain box. Remember, when we're growing up, we always said in computer classes, they always said the CPU is the brain box of the computer. It is the brain of the computer, the CPU. The CPU, it is the brain of the computer. If you remove the brain, it no longer functions. So what is the CPU? The control unit and the arithmetic logic unit of a computer system are jointly known as the central processing unit. So the CPU is the brain of any computer system. All major calculations and comparisons are made inside the CPU. All major calculations are made inside the CPU. The CPU is also responsible for activating and controlling the operations of other units of the computer system. One thing I like with the computer is that you can use layman examples you can relate with it, because, for example, you as a human being, do you know your CPU? Can someone tell me the CPU of humans?
The brain.
Thank you. Your CPU is your brain. So before you perform an action, you have already thought about it. Do you know that?
Yeah.
Before you perform an action, you have already thought about it. And where is the thought being processed? It's in your brain, right? The thought is being processed in your brain. Now, look at this last point. They say the CPU is also responsible for activating and controlling the operations of other units of the computer system. The CPU is also responsible for activating and controlling the operations of other units of the computer system. So if we want to relate this with our day-to-day life, what are the other units of our body? What are our other units? You have your hands.
The eye, the ear, the hands.
Thank you. So as I use an example, before you perform an action, you have already thought about it. Let's say you are currently seated there and you want to go to your room to collect a book. Your brain have already thought about it. And now your brain tells your legs that stand up, move 1, 2, 5 steps. Collect this book. You have to collect it with your hands. So your brain has told your other parts of your body what to do. Do we see the way it is very relatable?
Yeah.
Do we see the way it is very relatable?
Yes.
So any decision that you take in your life, it has already been processed in your brain. The fact that you decided to come and sit and take this course is because you had already made up your mind that this is what you're going to do at this time. You had already made up your mind that this is what you're going to do at this time. So all major calculations in the computer system is done in the CPU, also known as central processing unit. Let's go back to this diagram. We said the CPU is now further divided into 2 parts. We have the ALU, arithmetic logic unit, and the CU, control unit. Let's look at the arithmetic logic unit, what the arithmetic logic unit does. The arithmetic, please pay very, very keen attention. It's very important. We have to know the differences between the arithmetic logic unit and the control unit, because you may be asked the question in an interview or even during a public exam. So the arithmetic and logic unit of a computer system is the place where the actual execution of the instructions take place during processing informations. So those instructions or data that is being sent using the input unit, it is being executed at the level of the ALU. All the calculations, all the mathematical calculations, the formula, the operations are being carried out here, the arithmetic and logic unit. So please note that. Now let's look at the control unit. The control unit directs and controls the activities of the internal and external devices. Remember, I said that when you think about something, when you carry out an information, you have already processed that in your mind. Like, you have already taken the decision in your mind. That's the arithmetic logic unit. Okay, now what controls the other parts of your bodies? Like to say, okay, stand up, walk 3 steps, go and fetch water. It is the control unit. That is the second part of the central processing unit that does that. So the control unit directs and controls the activities of the internal and external devices. That's not all. Remember, the arithmetic unit, the arithmetic and logic unit processes the information, does the mathematical calculations, and now is being sent to the control unit. For the control unit to interpret the instructions fetched. So the control unit interprets those processed data, the processed instructions that was sent to it. It has to interpret and understand, okay, what does this mean? After it has interpreted, it has successfully interpreted, it determines what data are needed, where it is stored, and where to store the operations. Are we together?
Yes.
Are we together,
Yeah,
guys?
we are together.
Yes, so yes.
So the arithmetic logic unit takes the data, it performs its calculations. It's an arithmetic calculations. And now the control unit interprets it to understand that, okay, this is what it meant. And now it redirects the other parts of the computer to perform the interpreted data. It also sends the control signals to the devices which are involved in the execution of the instructions. Are we together, guys? A lot of people tend to be confused here. So please, I want to make sure that I'm not going too fast. Am I going too fast?
No.
There's only one person answering things. Why
No,
the
you're
others?
not too fast.
Can the others also answer? I want to be sure that no one is left behind. From next class, I will be calling at random that, hey, please help us read this. And I will explain just to make sure that we are all interacting. Okay. And to make sure that nobody is sleeping, because sometimes we tend to sleep during live classes. So once in a while, when I ask that, are we together, you can unmute your mic and just reply. So are we together?
Yes, so yes.
Yeah.
Thank you. So let's look at, let's go back here. We have seen the first part of the system unit, which is the control unit. We have spoken about the two different parts of the control of this CPU. Sorry, we have seen the first part of the system unit, which is the CPU, central processing unit, and we have spoken about the two different parts or components of the central processing unit, which is the arithmetic logic unit, control unit. Arithmetic logic unit performs the arithmetical calculations from the data or instructions that have been sent into it, and the control unit interprets and sends information to or redirect the other part of the computer that are to perform the task that was assigned to it. So now let's look at the second part of the system unit. Let's look at the second part of the system unit. We have the memory, the main memory. We have the main memory. The data and instructions that are entered into the computer system through the input unit are stored in the main memory. Similarly, the results produced by the computer after processing must also be kept in the memory unit. Memory unit provides space for storing data and instructions. It also provides space for intermediate results and space for final results. Okay, so let me explain what this means. So basically, what does the main memory does? You know that when we send the data or the instructions into the computer system, we can be sending because you know a computer can perform a lot of tasks at the same time, right? Are we together? You can be playing your music while you're typing, while you're watching a movie. So those instructions or data that are being sent into the input unit, it's not like many instructions are being sent at the same time. Okay, but the computer processes each instruction one after the other. Are we together? The computer processes each instruction one after the other. It just right now we cannot actually see it. We cannot actually know it because it processes those instructions in a minute of milliseconds. That's why you can think that is multitasking. in the early days, the very first computers were very slow. You are going to, let's say, if you type a button on your keyboard A, it's going to take like 5 minutes to display on your screen. You see, right? But right now, if you type AB at the same time, it's going to appear at the same time. But the concept has not changed. The only thing that has changed is it has been improved, the speed. So this is what happens. When you send the first data or instruction to the central processing unit to process, and you send the second one simultaneously, the second one is being stored temporarily somewhere. And that temporal location is the memory unit. So that once it's done with the first instruction, once it's done with performing the first being queued up, instructions are being piled up. One is the first come, first serve, one after the other. They're being piled up, one after the other. So when they're being piled up, they have to be stored somewhere temporarily. And they are stored, where are they stored? In the main memory. The main memory is responsible for storing this data. And after they have been successfully processed, they have been sent to the output, because it's not all data. Data is not destroyed. How we know that information is not destroyed? So they have to be stored back permanently or temporarily. That's why we have the hard drive, we have our flash, we have our USB keys. And where is it stored permanently? What is the device that is responsible for doing this? Or the component? Is the memory unit. Are we together?
Yes.
Are we together, class?
Yes.
So we must know the different, must know what the different roles that these components have to play. That's why you see these arrows. It tells that they work hand in hand. Okay, look at this ALU. Look at this arrow leaving from the ALU to the CU. And at the same time, there's also an arrow leaving from the ALU to the main memory. What does that tell us? When instructions or data is being sent to the system unit, the first instruction that was sent, it has to be processed here at the level of the CPU. And the second instruction, third, fourth, fifth, sixth, when it's being sent, it is sent straight to the main memory for temporal storage. It is sent to the main memory for temporal storage. Once the CPU is done processing and it has understood the instructions, it goes back to the main memory and collects the second instruction that was sent to it. Does this make sense? Does it make sense, guys?
Yes.
It does make sense.
So you see, that's how the computer
Works.
works. That's just basically, you see this diagram? This is how the computer works. When I talk about the computer, any electronic device that processes data, your phone, this is how your phone works. Because I hope you know that your phone has a CPU. This is how your phone works.
Yes.
This is how your calculator works. This is how your games, your game parts, this is how they work. This is how your watches, all of them follow this architecture. Input, system unit, output unit. Input unit, system unit, and then we have the output unit. Are we together?
Yes.
Okay,
Yes.
now let's look at, they say the computer memory is made up of two basic types. We have the primary memory and we have the secondary memory. Primary memory such as RAM and ROM. Secondary memory, for example, we have the hard drive, CDs, pen drives. Can someone tell me what RAM and ROM is, like their full meaning? Can someone help me with that, please?
RAM is random access memory.
CPU and ROM.
Read-only memory.
RAM is random access memory. ROM is read-only memory. So we have to know what their main functions. So random access memory is primary volatile memory, like temporal memory, very volatile. What does it mean? Once you off your computer, it's lost. It's not stored. So the instructions or information that are stored in the primary memory, in the RAM, sorry. The information that are stored in the RAM, they are stored temporarily, so far as your device or the electronic device is working at that moment. Once the electronic device shuts down, the information or data is lost. So we said the random access memory is a primary volatile memory. So the opposite is for the case of ROM, read-only memory. The primary non-volatile. What does that mean? So whether your computer or your electronic device is on or off, the data, the information is not lost. It is stored permanently. So non-volatile. So that's that. The ROM and the RAM consists of the primary memory. Let's look at the secondary memory. Secondary memory is used to store data permanently. Secondary memory is used to store data permanently too. And we have, for example, we have the hard disks, we have the CDs, we have the DVDs. Remember, in those days, we used to store data in CDs, but right now we don't use that again. We mostly use the hard drive. Every computer has a hard drive, an internal hard drive, or an external hard drive. You can purchase an external hard drive. We have USB keys, flash drives. Okay, please look at this diagram beside here. Look at this diagram beside here. You see this first diagram, right? Look at these little chips, like this little kind of like square-shaped object. This is what we call the RAM. The ROM. Non-volatile. And look at this down here. This is called the RAM. If you have ever opened a computer before, either desktop or laptop, personal computer, you're going to see this there. RAM.
Okay. Can I ask
And
questions?
you know that
or
when
question
purchasing
is
your
at the end?
computer, they always... Yes, you can ask a question.
Yeah, I just wish to ask that when working
Go ahead.
on your laptop, maybe you're on Excel or Microsoft, and your
Yes.
machine suddenly slip off.
Yes. Or goes off.
Sometimes yes, it goes off, and then sometimes you put it on, maybe it could be as a result of battery or so, and you put it on. When you open maybe a new Word page, there are other informations there that they say restore and things like that. Are those information stored on which memory do those information get stored that maybe they're asking you to restore also?
On the ROM. So this is what it does, because you realize, well, for example, like Microsoft Office, at first it did not used to be like this. At first, I think 10 years ago, if you're working and you're not saving your work and your computer unexpectedly shuts down, you have lost everything if you do not save it. But right now, they have improved the software in a way that when you are working, it does some auto saves. So it saves for you in the background. Not all, though. Periodically, it auto saves. That's why when your computer unexpectedly shuts down and you put it on back, you are going to see they say recovery.
Mm-hmm.
Have you ever, when you try to recover, you see that you have recovered some, but not all, right?
Yes, maybe the thing that was in the last 5 minutes, but the most recent things you type were not there.
Yes. Yes, because it only saved the work, what you were doing 5 minutes ago.
Mhm.
You see, right? So
Okay.
it saved here at the level of the read-only memory.
Mhm.
Now, what you're supposed to do is when you save it, when you click save as or save, it does not save on the read-only memory. It goes to your secondary memory, which is the hard drive or your
CD, the
flash.
bits.
So read-only memory is temporal.
Mhm.
Temporal. Secondary is permanent.
It's permanent.
Read-only memory is temporal. Secondary. So was your question understood?
Yes, thank you.
Answer.
Yes.
Okay, let's move forward. So I was trying to say something here. You see, it's good to have some a little bit, just a little bit of hardware and maintenance skills so that you'll not be cheated. You know that this, if you realize when you're trying to purchase a computer, they give you some specifications like, okay, you want to purchase a computer, let's say an HP ZBook. They say an HP ZBook, the RAM is made up of 16 GB, the hard drive is made up of 1 gigabyte. Who is familiar with that? Who is familiar, please?
Yeah, I think I've
So
come
do
across
you
that.
know that there's a way for you to know the capacity of your RAM on your computer without
Mhm.
necessarily opening it? Who doesn't know? Should I show you guys?
Yes, I
Let
don't
me
Please
know.
say
I
it.
do.
know that you
Yes,
must open and check.
it shows.
This is good to know this so that what if you're going to queue. For example, this is how you go to you. Are you guys seeing my screen?
Yeah.
What is currently displayed on my screen?
Mhm.
It's still a PowerPoint on my own screen.
Mm.
Is it still a PowerPoint?
Yes.
Let me. Are you seeing?
Yeah.
So as I'm demonstrating, if you can just try to verify your own computer too. So go to open any folder. You go to this PC where you see this PC. Navigate to this PC. Go to properties. Click on properties, and another window is going to open. Are we together?
No, not yet.
Not yet.
Okay. Go to this PC. Let me do it again.
Yeah,
Open
this
any
PC.
folder,
Mm-hmm.
any file. Just go to this PC, navigate to this PC. Now, right-click on this PC. If you are using an old version, you'll see my computer. In the place of this PC, you're going to see my computer. Right-click and go to the last option where you see properties.
Mm-hmm. Properties.
Right-click and go to the last option where you see properties. Then click there. A new tab will open.
Mm-hmm. You have about.
Are we together now?
Nope.
Okay, Ms. Francine, what are you facing an issue?
Yes, I'm looking on my laptop. I went to start, but I don't see.
Okay,
Okay,
where are
let
you
me see.
right now?
Right now, I'm seeing all I'm on setting.
No, no. Open a folder. Open a folder.
Oh, okay.
Do you
Any
know what?
folder?
Yes, any folder.
Okay.
Like right now, this is a folder that is opened on my computer.
Okay, yes, I'll open new folder.
Okay, look at your left side. You see, look for an icon where you see this PC. Oh, my computer.
This PC, my computer, desktop, my computer.
Look for an icon there called this PC.
Yeah, this
Oh,
PC. Yes, I got this
okay.
PC.
Navigate there, right click there as I just did.
Yes.
Go to the last options. Look where you see properties.
What is this?
Properties. Or like you're going to see a drop down list of options.
It shows me Windows and network. Huh.
No, you should see properties. When you right click on this PC,
Okay.
just look at my screen. Right click, you see properties.
Okay. Let me see. Go back.
Guys, are we following? Are the others following?
Yes. There
Yes.
I've seen
No.
device
Okay.
specification.
You should see device specifications. You see device name. You see processor. Look at where you see installed RAM. Mine here
Yes.
is 16 gigabyte, bracket 15.8 gigabyte usable.
I have 8 in bracket 7.89 gigabyte
Yeah,
usable.
so you have your gigabyte capacity, your RAM capacity is 8 gigabyte.
You know what? When
So
I
it's
click
important to know how to. Yes, Mrs. Francine.
when I click when I make right click, it gives me device and the drives. It shows me Windows 163 gigabyte. So I don't know what is the property.
Okay, you clicked. You do not right click. You instead right click. I mean, like you're using a laptop, right?
Yes.
So right click to you see to the bottom right of your mouse. Bottom right of your mouse. Click there.
But,
So your cursor should be on the icon,
May-
this PC.
Maybe
This
she can
PC,
share her
yeah.
screen. Let's help her out.
I'm not on the class. I was using my phone, so now I'm on computer. I'm trying to see this PC.
Can you share the screen of your computer?
No,
Uh,
she's
I'm not
logging with her
logging.
phone, not.
Okay.
Yeah, this PC. Yes, I got on this PC.
This you see this PC. Right click. I just need you to right click. Bottom right of your mouse. Bottom right.
Make sure the cursor is on this PC before right
Yes.
clicking.
Like look at me here. The cursor
Oh.
should be there. Look at this hand gesture. Right
Yes.
click.
Right.
Click, you'll see a drop down. Are we together? Are you there now?
That's okay. Hold on. Let me see. Let me go back on this PC. Okay. No, nothing came. It just should give me the option of device and drive.
Okay,
Click
anyways,
on this
after the
PC.
class,
Make sure
I
that
can
you
help
click
you.
on the PC. Click on it once, then you right click.
Anyways, Mrs. Francine, after the class,
Yes.
you can contact me. I'll help you with that.
Yes, I will.
So
This
guys,
is-
it's very important. Look at this installed RAM. Mine is 16 gig. So why am I saying it's important to know this? So for example, you can going to purchase a computer. They say you want to purchase an iCore 7th generation computer. You give your specifications. You say you want a RAM of 16 giga or 32 gigabyte. You want a hard drive capacity of 1 terabyte. And the guy, you give your money, the guy gives your computer. But how will you verify that you are giving the right stuff or what you order.
Right. Mm.
So you see that you must know this kind of little tricks. You just open your computer right in front of him, you open it, you navigate to this PC, you click on properties, and you are going to see the major properties of your computer. These are the main properties here.
Mm.
I
Look
have
at
a
your
question.
processor
Oh,
speed.
excuse me, please.
Yes,
Oh,
go ahead.
somebody said before me. Yeah.
Yeah, so in this scenario,
Okay.
I'm watching you, I'm looking at your screen right now. I'm trying to figure out. So in this your own PC, what is your gigabyte? I see something like say local disk 148, local disk again.
Okay.
Yeah, so how do I rate this? Thank you.
Okay. What you are looking at is your hard drive capacity. Like when you click on, you see a local disk, right?
Local disk.
Yeah.
Local disk C, local disk D, you see Wisdom. My hard drive capacity, my total hard drive capacity is 500 gigabytes. So I've partitioned them into 3. That's an more complex something now we'll see later. I partition them into 3. So that's your hard drive, like your secondary memory, your permanent secondary memory, where you store all your stuffs in your pictures, your files, your folders, your videos. They are being stored on your secondary memory, your internal hard drive. This is where you see them. So mine is partitioned into 3. Local disk C, local disk D, and I gave another name, Wisdom G. So this is my hard drive. But what we're looking at, we want to see the capacity of our RAM, our random access memory. So could you locate that? The person that asked the question.
Let
I
me
think it was.
see. Your RAM.
Okay.
Your RAM.
Mrs. Rita, could you locate your RAM?
Actually, not yet.
Okay, do you need help with that?
No, I think I'm good on that part. I'm good. I understood everything. I know how to go about it. Yes.
Okay, that's good.
So I just wanted to ask a question because you said we could check without opening the computer. So I thought it was something different. So I was like, I didn't really understand that part. Like, can you know, do you know that
No,
you
what
can
I meant
check?
was that,
Yeah. Mhm.
look at you, can you see my screen?
Yeah, sure.
This is what I meant. I was saying this, look at this device. The RAM that we just looked at right now, the specification on our computer, this is how it looks like. Its physical appearance. This picture
Okay.
down here that you see I'm moving.
Mhm.
So you should be able to know, well, you should be able to know this when you see it physically, like physically. If you
Okay.
open your computer right now, the laptop that you're currently using, you're going to see this. But with a laptop, okay, look at this third image. This is exactly how the RAM of a laptop looks like. It is short, very short. But for a desktop computer, it is longer. Look at these first 2 images. These are the RAMs of a desktop computer. So before you see it physically, you have to open it. And look at this image up here, the ROM. This is how the ROM looks like. It's small chip, very small chip. Also here, you come back here to this image. This is how your CPU looks like. If you open your computer, your laptop, this is how your CPU looks like. But the CPU of a desktop is big. You can see it physically. And for a laptop, you need to open the back of it before you can identify it. So are we together?
Yes.
Okay, so that was it about computer components. That was it about computer components. So computer components was spoken about input you need using the input devices. The next class we'll talk about the input devices, some input devices like the mouse, the keyboard in more depth. We'll also talk about some output devices too, like the monitor, the speaker, in more details. So the 3 main components of the computer, please. put in mind that the three main components of a computer are the input unit, the system unit, and the output unit. The system unit is the most important. It is the brain of the computer. So the system unit is made up of two main components. We have the CPU, also known as the central processing unit, and we also have the main memory. Let me repeat myself again. We have the CPU, and we have the main memory.
Main memory.
The CPU is further divided into two other components called the ALU, also known as the arithmetic unit, and we have the CU, also known as the control unit. The memory, we said the main memory is for either temporal storage or permanent storage. The main memory is for either the temporal storage or the permanent storage. And we said the main memory is divided into two types. We have the primary memory and the secondary memory. Primary memory is further divided into two components, which consists of the random access memory, also known as RAM, which is a very volatile memory. And we have the read-only memory, ROM, which is a non-volatile. So please look at the diagrams very well and memorize them, because you should be able to identify an object if it's given to you. Imagine in an interview, you're given one of these, they tell you that identify this, what is this? So you should know that this shape is this one, this other shape is this one. You should know the differences, the physical differences between the RAM and the ROM. You should know the physical differences between the RAM and the ROM. You could even be given a desktop, a CPU of a desktop computer. They tell you, okay, they tell you that open it. Show us where the RAM is. Show us where the ROM is. And show us where the motherboard is. I'm not speaking about motherboard. We'll talk about that later. The motherboard is another important component that consists of the CPU. Important physical component. So are we together?
Yes.
Yeah, we are.
Yeah.
I don't know. It's right now it's 2:30 a.m. Sorry, I'm located in I stay in Cameroon. That's where I stay. So right now it is 2:30 a.m.
Oh
So
my
it should
God.
be
Wow.
That's late.
Wow.
it's okay, I'm used to it.
Thank you for taking your time. I mean, this is really a sacrifice. Thank you so much.
You're welcome.
Mhm.
So do you guys want break? Should we give a break or should continue? We usually give 10 to 15 minutes break.
So me, I think we should continue because it will end the next 30 minutes. So I don't know. Just
It's
continue.
better we continue. It's late. You need to
Yeah.
catch some sleep, man.
All right. Okay, let's continue. It's 2:30, so it will be done in the next 30 minutes. Let's look at some commonly known computer technologies. In your day-to-day life with computers, you have to know some common words that we talk about every day in the world of tech, in the world of technology, in the computer world. For example, information technology. What is information technology? It is the use of technologies from computing, electronics, and telecommunication to process and distribute information in the digital and other formats. It includes not only the use of computers, but also communication networks and computer literacy. So you see that information technology is not only limited to computers. Anything digital that we use to process, anything electronic that we use to process information, that we use to distribute information using communication networks, all that forms what we call information technology. So it is the use of all these different components, electronic devices, computer, telecommunications, to process and distribute information in a digital form. So anything that enables us to distribute information is called information technology. Anything that enables us to process information is called information technologies. So it's not only limited to computers. Your phone that you use to communicate with your friend or your colleague, it falls under the scope of information technology because you use it to distribute and you use it to connect with other people. Computer literacy, remember when our class started, we spoke about computer literacy. What is computer literacy? It involves the knowledge of the internet and the World Wide Web and the ability to take advantage of their resources and to critically judge information. So in a nutshell, someone that can use a computer and its components is called a computer literate. But someone that doesn't have knowledge of a computer and its component is a computer illiterate. So I want to congratulate you all because you all fall under the category of computer literates. Guys are not computer illiterates. So you should be happy for that. So you can be asked in an interview or in an exam that who is a computer literate, who is a computer illiterate? Those are very pertinent questions. So this is what I'm going to do, okay? After tomorrow, because our classes are Mondays and Tuesdays. So tomorrow, it will be the last class for the week. I'll give a set of questions that we're going to answer during the week and we'll revise it the next week. Do you guys like that? Do you like that method?
Yeah, that will be helpful.
Yeah, it's okay.
And these questions are very important questions that you may be asked in interviews or exams. Like you may be asked simple questions. There's a set of 50 questions, so you just take your time. You can answer 10 questions per day. Please keep it jealously. So you may be asked in an exam or in an interview, who is a computer literate? What is information technology? What is the difference between information technology and computer literacy? What are the components of a computer? So you may be asked these pertinent questions. Okay, let's look at the third terminology that we see in our day-to-day life. We have a computer program. What is a computer program? It is a set of instructions written in a programming language that a computer follows to perform a specific task. Please do not confuse a computer and a computer program. You may be asked, give the differences between a computer and a computer program. We said a computer is an electronic device. So actually, a computer is already a hardware. A device is a hardware, something that you can touch, feel. It's an electronic device that takes in data, processes, and produces the result through the output. Now, a computer program is a set of instructions. So you can, it is already, that means that software you cannot touch, you can only see. It is a set of instructions that are written for the computer to follow. Computer programs are a set of instructions that are written for the computer to follow. And usually these instructions are written in the form of a programming language. Remember, I said, what is the language of a computer? A computer does not understand plain English. Like you can't be writing here, good morning, how are you doing? No. A computer has its own language called programming languages. So for you to communicate with the computer, you must feed in instructions, tasks to perform, and you must feed it in its language that it will understand, not in your language. You have to feed it in its own language. That's why we have computer programmers, people that can code. And we have many different computer programmers. We have different programming languages like Python. You guys are doing cybersecurity with Prof. Fabrice, so you surely see these kind of things. We have Python, we have Java, we have C, C++, we have Ruby. So we have a lot of computer programming languages. So these instructions can tell the computer how to process data, execute operations, and produce desired output. These programs can range from simple scripts that automate small tasks to complex applications like operating systems. For example, your phone, when you put your alarm clock that you want to wake up every day at 1 a.m., all you need to do is just go to the app, you set it up that, okay, 1 a.m. ring. But you know what happens in the background? There are a set of instructions, complex instructions that were written to it so that, okay, do these mathematical calculations, and at this certain time, perform this certain task. So that's why I say programs can range from simple script. As you are sitting there, you can write a simple program to tell the computer to perform a simple task. Like you can code a calculator. In my university days, those are things that we used to do. Write simple programs, we code a calculator. I remember I once wrote a program in AI to, I think it was to calculate, to study some data and produce some analysis, study data, analyze it, and produce some results. I don't remember very well, but those were just simple things, They say to simple scripts that automate small tasks to complex applications like operating systems. Operating systems. What is an operating system? We're going to see that in the next class. Operating systems like Windows. You have Windows, you have Linux, you have Kali Linux, you have Ubuntu. So those are computer programs that were coded. Very complex. Some are open source. We have ChatGPT that we use every day. We have DeepSeek that has come now to overthrow ChatGPT. Those are computer programs that were written in the computer language using computer programming languages. Very, very complex stuffs that you cannot understand with plain English. So basically, that's what a computer program is. So the next terminology that we're going to look at. Are we together, guys?
Yes.
The next terminology that we're going to look at is being online. What does being online means? That is using the computer to access information from another computer through the use of a network. So currently, you and I were online. You're using a network to access my computer. You're looking at what is displayed on my screen right now. You can read what is displayed on my screen. Meanwhile, we're not physically in the same location, and we use that using the internet. So you're online because you have access to information from another computer using a network. So we are connected using a network. That's what being online means. Let's talk about the internet. The next term or terminology that we'll talk about is called the internet. Internet is defined as a global network of linked computers, servers, phones, smart appliances that communicate with each other using transmission control protocols, standard to enable the fast exchange of information and files along other types of services. So in a nutshell, what is the internet? It's a global network that is made up of computers, made up of servers, made up of your phone, your watch, appliances that we use to communicate with one another, we transmit information we transmit files, we talk with one another. So it's a global network of all these electronic devices. That's what we call the internet. Now, the next terminology is the World Wide Web. And many people tend to confuse the internet and World Wide Web. You must know the differences between the internet and the World Wide Web, that is WWW. World Wide Web, also known as Web, WWOW3, refers to all the public websites or pages that users can access on their local computers and other devices through the internet. So you see that for you to use the World Wide Web, you must use the internet. The World Wide Web is accessed through the internet. So it is a list, it's just websites. Websites that have pages. When you go online, you want to research, you say meals in, let's say meals in Texas, list of meals in Texas, or you are trying to order a meal online on a website. It means you have to visit that website. You have to look at its catalog, its menu. What you are doing there, that's what we call the World Wide Web, because you're accessing a list of pages on the internet. Are we together?
Yes.
Yes.
Are we together, guys?
Yes.
Okay, we have email. Email also, which means electronic mail. Can we ask this kind of simple question? Oh, that what is an email? Commonly shortened to email. It's a communication method that uses electronic devices to deliver messages across computer networks. So we have a lot of email services, like we have our Gmail, we have our Yahoo Mail. So there, I think they are also on Outlook. There are lots of them, but the most common is Gmail and Yahoo. So they're just communication methods that use electronic devices for communication. When you hear email, the only word that should come into your mind is communication. There are two things that should come: communication and internet. That's all. Information technology. Okay, we already saw this. Okay, cyberspace. What is a cyberspace? It encompasses the whole wired and wireless world of communication. So both wired and wireless. That's what we call cyberspace. We all are in a cyberspace. Okay, we're going towards almost done. Okay, let's look at something: hardware versus software. Remember, at the beginning of this class, I mentioned hardware and software, and I said we're going to look at in-depth along as the class goes on. Okay, so look at this diagram. Look at this diagram here. This diagram depicts the basic demonstration of the hardware and software. Before we talk about different types of computers, let's talk about two things all computers have in common. That is hardware and software. All computers. Remember, I said computers is not only your laptop or your desktop. Even your phone that you're using is a computer. Even your watch, even your calculator. And you agree with me that they are made up of two main components if you've understood them: hardware and software. First, hardware. Hardware is any part of your computer that has a physical structure. A physical structure, such as a keyboard or mouse. So hardware is anything that has a physical structure. What does physical mean? Is you can touch it. You can see it, you can touch it. It's tangible. So hardware is any part of your computer that has a physical structure, such as a keyboard or the mouse. It also includes all of the computer's internal parts, which you can see and touch. So all the computer internal parts that you can see and touch. Your keyboard is comprises of the hardware component of your computer. Even your RAM, all these things that we saw here, your RAM, your ROM, these are hardwares because you can touch them. You can see them physically and you can touch them. So all the physical parts of your computer that you can touch are what we call hardware. So even the cables, your hardware, your battery, your charger, hardware. Let's look at the software. Software is any set of instructions that tells the hardware what to do and how to do it. So what controls the hardware is the software. The hardware does not function on its own. What tells the hardware what to do is the software. And as we said, software is opposite of hardware. Hardware, you can see and touch. Software, you cannot see and touch. You can only see, but you can't touch. These are known physical attributes of the computer. So software is a set of instructions. Can you touch instructions? You cannot touch instructions. You can only read instructions. You can only see instructions, but you cannot touch it because it's not physical. So it tells the hardware what to do and how to do it. Examples of softwares include web browsers, for example. So we have web browsers, we have games, we have word processing like Microsoft Word. So for example, yeah, look at this picture. These are some examples of softwares. You can see their logos here. We have Word, we have this player, this video player, we have this big G, which is Google. We also have this other icon here that Instagram. This other one here, Spotify. We have this envelope icon here, which is email. So all these things are softwares, and they tell the hardware what to do and how to do it. Everything you can do on your computer will rely on both hardware and software. For example, right now, you may be viewing this lesson through Zoom, as you are currently doing, and it's being displayed on your computer screen. So the Zoom, in brackets, software, you connected through this call, you connected to this class right now using your software, a software called Zoom. And what did the Zoom do? It told your computer hardware, which is your screen or your monitor, to display it. So you connected, you may be, for example, right now you may be viewing this lesson through Zoom and it's being displayed on your computer screen, that is hardware. As you learn about different types of computers, ask yourselves about the differences in their hardware. As we progress through this course, we'll see the different computers and also often use different types of software. So let's look at some different types of computers that we have. Almost done. We have the most people, when most people hear the word computer, they think of personal computers such as desktop and laptop. I emphasize, computer does not mean only desktop and laptop. However, computers come in many shapes and sizes, and they perform many different functions in our daily lives. When you go to the bank to withdraw money from the ATM, that's the computer. You sent in your card, which is data, raw data, instructions, and it was processed in the central processing unit of the ATM. Because when you send in your card, you specify the amount of money that you want to withdraw. So that instructions, it was processed in the central process of the ATM and say, okay, you want to withdraw, let's say $1,000. And $1,000 was sent out to you using the output unit. That's a computer. It's an electronic device that performs tasks, receives information, receives data, processes the data, and produces the output called information. We also have scanning glossaries at the store. We use a calculator. All those are computers. So let's look at some in-depth types of computers. Most commonly used computers nowadays, we have the desktop computers. Many people use desktop computers at home and school. Desktop computers are designed to be placed on a desk, and they are typically made up of a few different parts, including the computer case, we have the computer case, we have the monitor, keyboard, and mouse. So I don't think I need to over-explain this. So it's self-explanatory, right? Desktop computer. We have laptop computers, and I'm sure every one of us here is using a laptop. Laptop computer, commonly called a laptop. Laptops are battery-powered computers that are more portable than desktops, allowing you to use them almost everywhere. So laptops are portable computers. Portable computers, you can move with it from one place to another, and they're powered by battery. So it must not always be socketed on a switch like you see with a desktop. With a desktop, you must connect to the switch. Once the light goes off, or when it is switched off, your desktop computer goes off. But with a laptop, you can charge it. After you charged it, you can use it for a certain amount of time. Okay, what are the tablet computers? Tablet computers, or tablets, are handheld computers that are even more portable than laptops, because you can put them in your bag, you can put them in your pocket. Instead of a keyboard and a mouse, tablets use touch-sensitive screen for typing and navigation. The iPad is an example of a tablet. We have the servers. A server is a computer that serves up information to other computers on the network. So these are very large computers, very, very large. Like you see those mainframe supercomputers. That's what we call servers. And you're going to see them you only see them in places like banks, big institutions like hospitals, in firms, in big company, in firms, or you see that they do this kind of heavy operations that needs supercomputers. So that's what we call servers. These are supercomputers. Servers are supercomputers, very fast. They process trillions of informations per second. Per second, not per minute. Per second, trillions. Whenever you use the internet, you are looking at something that is stored on a server. Many businesses also use local file servers to store and share files internally. So other types of computers, many of today's electronics are basically specialized computers, though we don't always think of them that way. Here are a few common examples. Let me just brush this out, don't explain too much. For our smartphones, many cell phones can do a lot of things computers can't do. They were supposed to be can't do. Oh, computers can do, including browsing the internet, playing games. They're often called smartphones. While wearables, wearable technology is a general term for a group of devices, including fitness trackers, smartwatches, that are designed to be worn throughout the day. These devices are often called wearables for short. We have game consoles. A game console is a specialized type of computer that is used to play video games and we have TVs. Many TV shows include applications or apps that let you access various types of online content. For example, you can stream videos from the internet directly into your TV, like your Netflix and the rest. What are PCs and Macs? PCs means personal computers. Personal computers come in two main types, that is PC and Mac. Both are fully functional, but they have different look and feel, and many people prefer one or the other. So what are PCs? What is a PC? That is personal computers. This is a type of computer. This type of computer began with original IBM PC that was introduced in 1981. Other companies began creating similar computers, which were called IBM PCs compatible, often shortened to PCs. Today, this is the most common type of personal computer, and it typically includes the Microsoft Windows operating system. So we have the Mac, the Macintosh. I'm sure some of us here use Mac computers. Who here is using the Mac?
Is it what they call MacBook?
It's only yes, MacBook too. There's MacBook. Or Mac like Apple. Are you using an Apple computer? Yeah,
No.
that's a Mac. Did you know the full meaning of Mac?
I just know that is for MacBook. I don't know what that is Mac. What that is Macintosh.
Yes, Mac means Macintosh. Imagine you are being asked this question in an interview exam. These are the kind of questions you get.
My first time hearing that is
Yeah.
the FM is wow.
So you see that this class is really important. Mac means Macintosh or Macintosh. Macintosh is the full meaning for Mac. It was introduced in 1984, and it was the first widely sold personal computer with a graphic user interface, or GUI, pronounced GUI. All Macs are made by one company, that is Apple. So Macs are made by the company Apple, and they always use the Mac OS operating system. So the operating system is called the Mac OS. Meanwhile, for Windows, it is Microsoft operating system. Next class, we're going to look at operating system so you understand this in more details. So the last part here is characteristics of computer, but I think you can read that on your own. Characteristics of a computer: speed, accuracy, diligence, valuable storage. So you can read that on your own. So this brings an end to this class. At the end of this class, I will send this in the group, okay? So you can download it and read it during your free time. So do you have any question, guys?
Yeah, thanks so much for your
Thank you so much.
The class was very, very interesting. Thank you so much. I learned a lot. I needed stuff like this.
Thank you.
I was sleeping on the couch and forgot. I only checked up and realized that there was some minutes.
You're going
Thank
to,
you
this is
so
just the
much,
beginning.
Wisdom. That was a great one.
Right.
Thank you. This is just the beginning. Honestly, you're going to realize that just what we call basic computer actually is not basic. There is
It's
a lot
not.
of things here that you're going to
We don't
discover.
know. Yes, we use
we don't
computer
know.
every day. Like me, I use computer every 5 minutes because the
But
job
you're
I do.
talking-
But there's a lot of I
Like-
don't know.
You see.
Still, yes.
Katabod, are you there?
I can't wait to learn the Microsoft suite. Oh my God, that's my really, really like the goal.
That will be next week. We'll start that next week.
I can't wait for that topic.
Yes, please prepare for that because it's going to take us some time. Like
Yeah.
Microsoft Word, Microsoft Excel, Microsoft PowerPoint.
Yeah, those ones I need them.
It's going to take us some time. So let me stop this. Let me stop. Let me stop the recording. I hope it was recording.
Yes.